geeky stuff that is relevant to doing scientific computing at scale. And our inaugural speaker is Adrien Thebo from Puppet Labs from Portland, and he'll talk to us about Puppet. And I'll just cede the floor. We can start.
We've already
it's informal. If you want to have questions, and also there's time for questions at the end if people want to hang on for that.
All right. Well, first off, I'm Adrien Thebo. Thank you very much for having me today. And I'm going to be talking about effectively why you should use configuration management, because everything's going to change anyways. So let's start with some introductions. I'm currently a software developer at Puppet Labs. Been there for about 2 years. Before that, I was an operations engineer at Puppet Labs, so I've been on both sides of developing a configuration management tool, and I've had to use the configuration management tool. So it's been a good experience to see exactly how things work and how users are affected by them. So beyond that, I do a lot of open source work, and it's really exciting to be able to work on a lot of projects. Puppet itself is open source, and it's nice to be able to give back to the community. So let's start off with what configuration management actually is. That term is a very broad topic that just deals with managing any sort of change in a project. We're going to be specifically focusing on how this applies to software, and furthermore, how we actually use tools to control and manage change to software. So what configuration management gets you is, among many other things, it gets you 3 core things. It gets you consistency. You can get the same, when you're managing a system, you can get the same result every time. If you get a transient failure while you're setting up a system or modifying it, you can recover from that. And generally, it is a good way to manage state, and you don't have to worry about any issues while you're actually applying it. You can pick up where you left off. It provides reporting. So when you're making changes, you want to understand what's actually happening. So if you run a shell script, you may get some output, you may get like an exit value, but what actually changed, that's a lot more opaque. And so configuration management tools have a very good understanding of what you actually want, what the current state is, and how to reconcile them. So you can get an exact sequence of every single thing that changed while you're making changes. And if you have failures, it is very good at configuration management tools are good at explaining what failed, why, and possibly how you can deal with that. As sort of any sort of automation makes you more efficient. And so if you're able to create some sort of service hands-off entirely, you can set up 1 system at a time, or you can set up 10,000 systems at a time. So humans become much less of a limit. Do we have any audio?
There was a tiny burst of
How about now? Anything?
Oh, yeah.
Wait.
That's good.
Yeah,
All right.
Okay.
Okay, so Adrien will switch to his own laptop mic, so he'll sit there.
Let's actually get a slightly better mic.
Okay.
It'll be a little bit strange looking, but we'll roll with it.
well, I'm picking up signals.
Okay. Is
Yeah,
it clear?
so John cannot hear him, so
Okay.
we switch to
All right. So.
I would say just leave it as is and let's just keep moving.
Sounds good. All right. So where did we cut off?
about one slide back.
Okay. So did we right here?
Yes.
Okay.
Let's go through this index.
Okay, so to pick up where we were cut off, so with Puppet or many configuration tools, and with Puppet in specific, what you can do or what you do is you describe the end result of your system or what you want your system to look like to effectively get your work done. So in this example, we've got a couple of what we call resources, so a package resource and a file resource, and all we have to say is I want this package installed. I don't care how, just make it installed. And I want this file to be put in place with the contents that I specify. So instead of having to say, copy this file from this location, and if we're on AIX, we do one thing, and Windows another one, we just say, figure out the details, I want this file. So this way, you can write one code.
Whoever just joined us, make sure you're pausing the instruction. You found an LSST, there you go.
All right, so
Can't control these parts.
so this allows you to write one manifest or set of configurations and apply them to many locations, and it makes it very portable. So let's talk about this is a little bit about configuration management. So the question is, why does it matter? So I actually worked at Portland State University for a while. I was a sysadmin there, and one of the fun things about that is working with various research projects. We got the most fascinating of servers where someone had set it up about 5 years ago and had quit and didn't document anything, and no one dared touch it. It's some ancient server running some ancient unsupported software that no one can live about. No one understands it, and if anything goes wrong with that server, everyone is going to be in a lot of trouble because it is completely opaque, and there's a lot of laughter. Yeah.
We've never heard of such a thing.
Oh no, nobody. These are very terrifying things. I mean, the critical servers that no one understands. I mean, it's a dangerous sort of thing. I had to practice saying this word many times. So metathesiophobia is the fear of change and a mouthful. And it sounds like some sort of like horrible skin disease. You know, talk to your doctor if you think you have metathesiophobia. But it is in this or all change has some inherent form of risk. But if we're talking with some sort of special one-off snowflake server that no one understands, it's very brittle, it's terrifying, it's risky, and it's easier to just back off, never touch that thing, and just hope that nothing goes wrong. I mean, why fix was not broken? Everything will break though. You cannot escape change forever. Servers die, servers crash, you lose power, data centers fail, data centers catch on fire, and you have to recover from backups. So you, at some point, if you have these things, at some point you will have to own up that they exist, and you will have to effectively rebuild a lot of existing knowledge. Even if this scenario doesn't happen where you're having failures, that server may need to, or some mysterious Snowflake server may need some sort of modification. It may need better logging. It may need backups. Improvements are going to come along at some point. So information technology, any sort of large-scale operation where you deal with a lot of information, it exists in a maelstrom of change. You look back 10 years and think about how different the ecosystem was back then. And here we are. We're going to see this change continuing nonstop. So we have to live with this. So Snowflake servers are a really good example of where change isn't possible or possible at all. So let's talk about where change is happening but isn't desired. So I've got a couple of points that I want to draw out. So first off, servers have a desired configuration. I've seen one situation where we had a server that did not have a desired configuration. Its server name was shelf. It was because we didn't have enough rails and we stacked things on top of that. That's the one case where you actually don't care how it's configured. But in every other scenario, if you want to get anything done with a server, you have to configure it. So servers have a desired configuration. In addition, servers like to wander away from that desired state. This is entropy at play. Like, servers don't naturally coalesce to some desired state. Like, they don't accidentally get proper logging and backups. And if they do, I would love to know how. So things tend to degrade. So we have this sense of just constant change that is pulling us away from the state that we want to be in. So I'll argue there are two kind of subclasses of drift, state drift and informational drift. So the state drift, obvious case, someone shells into some server or some system and just makes a modification because they needed it at the time. So that changes in, and someone comes along later, they need to make a change that's necessary. It conflicts with the previous one, you get a failure. This can happen for any number of reasons, but this tends to build up until we can reach that vaunted state of snowflake server. You also have informational drift, where the server itself may be completely untouched, but people don't document things correctly. People quit. People forget it. We're fairly flawed devices when it comes to transmitting information, but in either case, we have a similar outcome where there's some unknown gap between the state that we want to be in and the state that we're currently in. So obviously, we need to manage this in some capacity. So a drifting server is a problematic server, and servers that drift too far become toxic. They're hard to understand, easy to break, and they become liabilities. So we need a way to prevent that. So we can use process, where if you need to make a modification or you need to do something, you have some sort of checklist, and you incrementally go through every single step, and you make modifications. Or you can make all the changes you need, and you can document them in some place. And this can start trying to deal with the fact of drift, keep things in a more consistent state. And this is where things like the IT infrastructure library and various things came from. And this, the IT infrastructure library, I'm not sure if it's more commonly aware of it, but it was invented or refined in the 1980s and 90s for large institutions to manage changes to their systems. So if you think about it, especially with the checklist approach, this is phenomenally backwards. Humans are frail, we're horrible at repetition, we've got terrible memory recall, and it turns out that there's something that's extremely good at repetitive tasks that are well-defined. They're called computers. So what we can do is, if we have a nice checklist that is do X, and then if Q, do Y, or do Z, you can just grab that and convert it to a script wholesale. This takes the human out of the factor. You will get consistent results every time, in theory. Let's say you take a checklist, you script it up, and you run it. How smart did you make that script? If something goes wrong, can it recover from it? If you're interrupted in the middle, can you resume the previous state? If you need to make a change to an existing server and bring up a new server, can you guarantee they'll be in the same state? Scripts are a nice way of handling this problem, but they're only as intelligent as you build them. So, what if you build in some sort of concept of your script of idempotency, where operations will only be applied once? Can you build in some way to do rollback on case of errors? Can you make it fail safely? Sure, you can do that, and you've invented configuration management. So with configuration management, as mentioned before, you describe your desired state in some sort of manifest or configuration file. You apply this using your chosen configuration tool, which should be Puppet, and you can see what changed and make decisions accordingly. So for an example, we have this configuration where, let's say we're managing OpenSSH. We can say, I want the server installed. I want the SSH configuration to be present, and I want the servers to be running. So let's say we cannot actually install the configuration. The file isn't readable or something like this, or we don't have access. But we do manage to install the server. Next time we go through, we say the server is already installed. We can leave it alone. We do need to put the file in place, and we'll probably need to start the service to get things going again. So this declarative model gives you idempotency. You can apply this as many times as you want. It's safe. If anything goes wrong, you'll be told about it, and so forth. So let's go into a little bit more depth about that, especially with, let's start off with consistency and idempotency. So I did this a few moments ago on my own server. I realized that I had an old user that I needed to remove. And apparently I had to put myself on my own server, so apparently I needed to do it. It's on, let's see, can we scroll? Now we can't scroll. Anyway, so this one says ashp@puppetlabs.com removed, Adrien@puppetlabs.com created. So the first time I ran it, it made those two changes. The second time I applied this change, it did nothing at all because it said, I've already made it, or everything is in the state that I want it to be. You can leave it alone. So the configuration for this is, I said I have this SSH authorized key I want installed, and I want to have one that I don't want to be present. It's pretty clear that I have like what's going on. There isn't an opaque script that I need to read through. I don't have to dig around for documentation. There is one authoritative source of truth for what things should be, and that's the configuration file for this. And the system will be brought to this state in whatever state is necessary. So there's nothing surprising. It is upfront. Here is what will be done. Another nice thing about this is we get proper reporting. So let's say I want to add a new user called Patrick, and I tried to add this user to a group with a group ID of 6700. It doesn't exist. The update will fail, and everything will, any other dependencies will fail because of it. So I can correct that mistake. But I can, let's see, I actually think that I created the user and then did some modifications, but if we need to just modify like a single property, like let's say we change the UUID, the next time I apply Puppet, it'll see the user's present, I'll just change the UUID, and if the shell is incorrect, then I'll change the shell from bin bash to bin zeech. So we get a very atomic sort of determination of what is the correct state, what is the actual state, and how do we reconcile them. So scale is another very big benefit of configuration management. This manifest, I could apply it, or since it is programmatic, it is able to more or less take care of itself. If I wanted to stand up 10,000 servers right here, right now, I could do it. So let's say I used AWS, spawn those 10,000 machines, run this on every single one, and now everything is set up exactly as I need it to. It is automation at its finest. So humans are limited. We tend to be single-threaded, and it turns out that if you can make something do parallelism for you, it works out pretty well. This is great for us if you are doing scientific computing at large scales. CERN is a really nice example of this, actually. They use Puppet. They have about 12,000 physical machines, and they have, on top of that, 300,000 virtual machines, because they are processing massive amounts of data. If they need to make a configuration change to all 300,000 at once, they just kick all those machines, they grab their new configurations, run it. This could be done within a matter of minutes. So reality is, everything is downsides. If someone tells you otherwise, they are lying to you and they are selling you snake oil. Configuration management has trade-offs, and I'm going to argue that these sort of trade-offs, they, by and large, they're good to make in the long run, but they're still trade-offs. So special snowflakes, I mean, if you have this one horrible, terrible service you just want to set up, you could just create, get a new server or something like that, or use an existing server, set it up by hand, and then try to dump this off on a postdoc or someone like that so it's never your problem, which is great. And if you have to go through and manage it with Puppet or something like that, you have to write these configurations. You have to test them. You have to make sure that, it actually is repeatable. This is time-consuming. And sometimes it's easy to just spin off a one-off that you'll never see again, and you just move on from that. So, as evidenced by the earlier comments I made about these Snowflake servers, this will come back to bite you. You may get away with it once in a while, but more often than not, the time that you'll save by doing this one-off upfront is going to be lost by the time that you have to relearn the systems, figure out what's going on again, understand what you have to do to modify the server in the future. So by not using configuration management, you are the configuration management, and you are the bottleneck. At my company, we have something that we like to call the bust factor. And it is how much information will be lost if you get hit by a bust right here, right now. So ideally, you want to have a bust factor of 0 where if you're hit by that bust, the organization will continue as usual. If anyone needs to make changes, they can understand what you're doing. There's another nice term for this, for the bust factor. It's called the vacation factor. If you can't go on, if you're essential, if you have information that only you know, if you're the one who set up the Snowflake server and no one else can touch it, can you go on vacation? Well, you're probably going to start getting phone calls in Hawaii, and I'm sure you're going to love that one. So my experience has been, I've used Puppet quite heavily. I've had these I will say there's some horrible things that I've done with Puppet because, you know, people do gross things, and if you're having to manage a gross service, it isn't pretty. But I've gone on vacation, and someone said, I need to change logging, backups are broken, I'm seeing errors. They can look at the configuration I've done, they understand the desired state, and they can reason from that and go from there. It is not opaque, it is clear about what they have to do. One of the procedures as well, maybe it's something like making some sort of complex decision and configuring some sort of service or something like that. Maybe you need to fine-tune some sort of variable. Maybe you need to enter a password. It's like 5 seconds of your time, and it may be 30 minutes to an hour automating this. So it's kind of nice to just go in, make the change, and be done with it. But this still gets us back to the same place where you are now an irreplaceable part of the system, and it's really nice to be able to go on vacation. It's great for your sanity. But beyond this, humans are always going to go back to the fact that we are good at making complex decisions and reasoning, but we make mistakes. We forget things. So let's say you're relying on someone to do some sort of manual process for you. You forget it. You're tired one day, and things come crashing down around you. It may save you time up front to just do things by hand, but in the long run, it will burn you down. So configuration management will inherently take some time. Configuration management is often referred to infrastructure as code, where you are specifying the behavior of your servers and how they connect to each other and the data that's involved. But you're still writing code. It's taking time. This could be time that you could spend actually using whatever service you want. This could be time that you could use for any number of things. And the initial point where you are managing a brand new service, it is costly. There's no way around it. If there's something that if you're in a rush, configuration management may make things more challenging. Getting the configuration process right, where it'll actually build things correctly, that's even harder, and it takes more time. Fundamentally, though, this time sink is extremely front-loaded. I've got a really good experience of this myself, actually. A while back, I had to manage this new service. Let's call it Muppet. This is a few years ago, and the first time I had to set up this type of application server with Puppet, it took a good week of trying to make some changes, debugging it, finding out that I suck at programming, apparently. It was a slow, painful process. Took about a week, and now I was done with it. And then something comes along where I need to stand up another server another Muppet server of sorts. I had to go back, and I discovered all the bad assumptions I made in the first time. So it took about first time took about a week. The second time to stand up this new server took about 2 days. The third time I stand up an app server, it took 30 seconds. It was, you make one modification, you start off Puppet, and you wait like a few minutes, and it's ready to go. And the fourth time it was 30 seconds, and the fifth time it was 30 seconds. And at some point we just said, we could just stand up another server and do it like that. Oh, let's just create a server that we can throw away. It was extremely cost-efficient, and just like a good way to drive home the value of this is, let's say doing it by hand will take about a day for you. So for the first, let's say 15 servers, you gain nothing. It'll be faster to do each one by hand. Get to 1,000 or get to 100 though, that'll still take you 100 days. With configuration management, it'll take you about 15 days and 291 seconds to stand up those 100 servers. So it's a front-loaded cost. It will pay itself off in the long run, if just for the time it's saving you. Not to consider the documentation aspect of it, the accessibility for coworkers or things like that. It will save you time. Oh, I'm burning through this presentation much faster than I expected, so I hope you guys have good questions. All right, excellent. So this has been a little bit fluffy. We're talking of managing an open SSH server or managing Apache or various things like that. But let's go with something more concrete. So continuous integration is all the rage these days. And the idea is, how can we develop code faster? How can we make sure it's going to work faster and things like that? So let's go into an example with Jenkins, or any sort of continuous integration tool will be able to provide this for you. But my best experience is with Jenkins. So I talked with Josh earlier today and yesterday, and we discussed a lot of really good examples of applications you used, and I had forgotten all of them. So, but I'm sure that there's some sort of code base that everyone's had to work on to develop that you have some new feature that you need to implement, and it takes, like, or so other people are working on it too. And to develop it and get it integrated and get it functional, it's a long cycle. It can take months, possibly years. And if you're trying to get it, like, if you need to get value out of this a lot more quickly, you need some process to iterate very rapidly. And the linchpin for a lot of these things is I've made a change. How do I make sure that it isn't going to crash and burn? Well, so the first thing we can say is, let's say we have taken the service and we have fully managed it with Puppet. So if the server that it's running on right now completely failed, we could create a new system or get a new server, run Puppet on it, and immediately get it back. So if we can establish a brand new server like this so quickly, why don't we, whenever we make a change, we just bring up another temporary server, apply our changes, and see what happens. Run through the testing, use automated tests, go through some examples by hand, try out test cases, and so forth. And so you'll be able to validate changes very quickly. So with a CI service, what you can do is, if you're using version control, you make your change. In version control, you push that off to one central location. You have a continuous integration server just sitting there waiting for changes to occur. You make a change, it grabs it, and what you can do is, if you're able to spin up these app servers, change comes in, you turn your app, a new application server, you put your code on it, you test it, you run through automated testing, you may eyeball it by hand, and if it works, you merge that code into your mainline branch, or you're ready to go. So, and if you gauge your process by saying all changes that are made must pass this testing phase, you can say at every single point we can ship. We're ready to go right here, right now. So this actually allows you to develop at an incredibly high rate. I mean, you have to have good tests, which once again will take more time, but you get the effect where it's front-loaded. You write the tests up front, and then you can just start making changes, throwing them at the wall, and seeing what sticks. You know that if your tests have passed, you are ready to go. So make a change, try it, see what happens. It crashes and burns. So what? It took you all of 2 minutes. So you can constantly churn out code very quickly. Anything that works, you can trust. And so you're constantly in a state where you can ship. So this could take, if you do 2-week releases or something like this, you can say, at this point, our build is ready to go. The features we want, we can ship. Go for it. So why are we just stopping at this 2-week interval of why aren't we, if we're always ready to ship, why don't we just ship? So if you've got an effective way of validating your changes, and you can always make the assertion of your main code branch is always ready to go, then if you get some changes that go through pass, you can push straight to production. And this, once again, builds on top of configuration management. If you can stand up an application server with your code, you can stand up another one, or you can update your existing application server. So a change comes in, it's validated, you do whatever packaging you need to do, and on your live application server, you can say, effectively, instead of having this package version 3.1.4 installed, we can we should say that the version 3.4.2 is installed. Puppet will go on and say, these things are out of date, I need to update files, update these packages, and restart these services. And so as an automated process, you make a change, it is entirely hands-off from this point out. You go through, you hit your CI service, you spin up a temporary server, validate it there, that passes, you go to your production server, and you update it there. So if you've got a new feature that you need to have live, it can be a 30-minute cycle or less. So using the old waterfall methodology, you would take the approach, you would spec out your requirements, like all the requirements for your next big release, and then you do all the design for those requirements, and then you spend 8 months developing all those features, and then another 4 months integrating all those features into a single build, and then you ship. But if you spec out your requirements for that one feature, you design what you need, you write the code that it requires, which could be a fairly small amount, you ship that. Once again, the difference between years and minutes is truly astounding. You have a request, you can have it done, you can have it ready to go. So if you find a bug, it shouldn't have to stop you at all. I mean, it'll cost you a few minutes. So I outlined the 2 options for deployment, or the first option for deployment where you can update a server in place. I don't think I've used nearly enough buzzwords in this presentation, so let's talk about the cloud. You're running some sort of your service, or you're doing some sort of computational or sort of reduction on, let's say, AWS, or you have like 500 servers that are just crunching away all the time. If you have a new version that you want to have, that you want to try out, you spin up another 500 servers, push the code into those servers, and you're ready to go. Let's say you make a mistake. That code isn't actually bad. You pull those 500 servers offline, you still have the original 500 ready to go. So we are in a continuous place where we can make changes very quickly. We can run them through tests. We can push them production. If anything goes wrong, we can immediately roll them back. And you can be in a situation where it is the release often and don't break anything. Wow, that was a lot faster than I expected. So cool. I'm out of slides. This picture was taken a few weeks ago. It is an Amazon data server that is, I believe, in Virginia. Fortunately, it was under construction, but it burned to the ground. So this goes back to the fact of change will happen if it happens to be that everything you love and like burns to the ground. Configuration management might be able to help you out. So, all right. That's what I have. Questions?
I'll have a look. Questions will go last.
I just wanted to know, everything sounded like it was Linux-based. Mac and Windows? Will Puppet work with those?
Oh, yes. Actually, I'll be a little bit smug and say that we actually have some of the best developers I've ever met working on the Windows team. Are you familiar with something called Chocolate?
No.
Okay, so one of the killer things about Linux for a long time has been the fact that you have a package manager. So if I want to have Apache installed, I just say install this package or something like that. There's this thing called Chocolate, where it is someone developed a package manager for Windows. Chocolate. His name's Rob Reynolds. He works for us, and he is awesome. So he does a ton of development for a Windows side of things. So the example that let's go way back. Wait, no, let's go a little bit farther. With this example where you have the Apache 2 package, Puppet itself has a concept of internally of having an abstract sort of concept of a package that is not platform specific, and then an implementation or a provider that is implementation specific. So to answer the question about Mac, we have the image provider, or we have the app provider, where if you've got a image, Puppet can go out, grab that image for you, unpack it, and put it in place. Or if you have just something.app, same thing, it'll just put it into place. For Windows, we can use Chocolate. So right now, I have I have this name hard-coded. On Red Hat, this could be HTTPD. On Debian, it'll be Apache 2. On Windows, it could just be Apache. So if you can just say, if I'm currently running on Windows, here's the package name. Otherwise, so you can throw in a case statement to resolve this. So our Mac support is Linux support is very solid. Mac support is making progress. We have packages for that available. You can manage a lot of things. I will say that OS X is kind of a completely mental platform, but we do a lot of work that if you're managing OS X 10.7, it'll work. 10.8, it'll work. And we can resolve a lot of these differences internally. We also support AIX for that matter. So, I mean, if you can support AIX, you can handle pretty much anything.
And when you were making reference to Apache with Windows, what about the native Windows components? I'm assuming those are configurable also.
So there are a few things that packages are a nice example where they are very portable across platforms. Files, once again, a file is a file is a file. But for things like Linux or POSIX-based platforms, they have cron. Windows has scheduled tasks. There's a very big overlap between those two different concepts. So in that case, if you don't have a good mapping across different platforms, if you're on POSIX, you use the cron resource. If you are on Windows, then you use the scheduled task resource. So another good example is file permissions. So with POSIX, by and large, you're going to have the basic mode where you've got user group other. That's one concept. You have kind of extended ACLs, but no one uses them effectively. And Windows has the terrifyingly powerful ACL system that it does. And so one of the things that Rob Reynolds actually has been working on is the Puppet Labs ACL module, which gives you a very rich way of interacting with all of the like just the ACL system for Windows. So what are some other good examples? Reboot. Not anymore, actually.
I was thinking like IIS, which is Microsoft's equivalent of Apache.
Yep.
You know, the web service, configurations for stuff like that.
Yes. So we have, I believe, an IIS module or so. I've been blazing through terms. But so with Puppet, a manifest is something like this file. It's just a list of resources. You can have a module which packages a bunch of like a manifest like this and possibly some additional information. So the module just packs that together. We have an IIS module that can install and configure IIS. There is a DISM module. I have not used Windows in a while, so I have no idea what DISM is, but I know that Windows users need it, and
Directory services.
it's what?
Probably directory services.
Yes.
That's just a guess.
Wonderful. Yes, so there's a DISM module. We recently released the SQL Server module for Windows as well, so we actually, I don't think we've done a very good job of talking about it, but we have very solid Windows support. Like, once in a while when I have to test something on Windows, I get Chocolate installed, I get Puppet installed, and then magic happens and my life is great. So we have very good Windows support. It continues to shock me.
Okay, cool.
So, yeah. Same thing. OS X, very good support. AIX, unfortunately, we have a pretty high casualty rate for the developers that work on AIX, but we have pretty good AIX support too. More questions?
I've got one. So this is managing your configuration. Can Puppet tell you what state the computer was in last week, or do you have to use Git or something?
You say, in the sense of, I make some changes, I make some changes, I make some changes, what was 3 revisions back?
Yeah, so, everything did actually work a lot better last week. But how do I find out what configuration Puppet was using a week ago?
That's where we start getting into the wider ecosystem. So Puppet is one small part of the entire ecosystem of, it is a thing that it can figure out what things change, or like it can figure out what your current state is. I actually can do English, give me a second. I get excited. So Puppet can figure out what your current state is, what your desired state is, and how to reconcile them. In addition, it has this concept of auditing, saying, Puppet runs my system and say, I made these changes, here's what this resource is. Like the horrible intern that likes screwing with things randomly, he shells in and makes some random changes. Puppet can go in and say, I set the state to X, it's now Y, and I want it to be Z. So it can say, someone made changes outside of the management process. So you do have auditing in that sense. And you do have historical information as well. This goes into something called Puppet DB, where as it's running, Puppet generates a lot of information. Like the cycle is, you want to run Puppet. First thing that happens is the agent comes alive and says, what are my current facts? Like, what's my operating system? How much RAM do I have? How much is free? And so forth. It sends that to a centralized location called the Puppet Master. The Puppet Master will say, I have these facts, and I can configure to provide these manifests. And it will send a catalog. When the catalog is it's just the complete desired state of your system. And that'll get applied, and when Puppet is completed, it will take all the changes that it'll made and throw that into the report. So you have facts, you have catalogs, and you have reports, and all these can be stored in something called Puppet DB. We have, for the catalogs, I don't think we do historical catalogs right now, but for what was the state of the world a while ago, we do have historical reports. So because there is so much information generated, even if we don't do it right now, it's very easy to, you can hook an animal instance and say, grab this date, keep this information, and so I know there's definitely some degree of historical information. There are historical reports, there might be historical catalogs, and if not, they're coming. And if you need more information, then we currently have a tool built for it. It's very easy to hook in and edit.
You're talking about configuration management of Puppet. Is that what you were talking about?
Yeah, so
so if you have revisions of your Puppet modules, or revisioning
the code
versions
itself.
of your, I want to go version back on what I did with this module or what I did with this config.
Josh?
That's it, right? Or what?
So
it will tell you what the state of your configs were, but it won't tell you that was actually applied. Right?
In that case, it wouldn't. But so yeah, is there anything integrated with Puppet?
Oh, funny you ask.
Because that was, I actually installed Puppet, and I actually got to that point with it, and I'm like, you know what? I'm not managing my configuration
Your
now.
software worked brilliant in master, and you tweak all the configuration or whatever in the week that follows, and then suddenly your software that was working doesn't work anymore, and you want to go back to how it was a week ago, so you can make sure it still works with the new version of the software.
So you need revisions of your Puppet.
Yeah.
Yeah.
I mean, if all you can do is check out your repo and reinstall Puppet.
So let me ask a related question. Actually, I don't know what the question's were. It was supposed to be on mic.
Sorry, don't mind my
No, it's picking up on the
It's picking up, okay. So going back to the stone example, so you have the 30,000 or whatever nodes.
Before we move off topic, why don't we let him field this question?
Well, I think it might be related. So
Okay.
let me go to that. And then you can tell them if they're not related and fill them separately. So in scientific computing, you know, it's not like it's not like a SAS in the sense that there are things that are more important than uptime. And one of the things that's more important is accuracy and reproducibility, right?
Yes.
So, you know, from the little I understand, you know, you know, if you're running a software as a service, how they deal with new versions is they have this rolling, which each instance goes down, it comes up with a new version, and you never go down because there's always 25,000 instances running, and whoever comes in and connects gets whatever instance they get, right? Now, you know, if I can imagine a situation where the reason I'm rolling out change, and in fact would be the predominant situation, is that either an algorithm has changed or in fact an algorithm is buggy and we're rolling an improved version. Now, at that point, it's probably worse to have some data being farmed at some nodes that are still with the old system and some in the new system, right? So part of the thing that I need to know is, have all machines acquired their new state? You know, so it's another way of, you know, it's another reason you want to know what machine the state is on, and I only want to start processing for real when the machines are known to all be in the new state, because I don't really want to use the old state anymore because it's known bad. So, okay.
Different question, but I can also keep, you all probably started knowing, like, noticed the grin that was just kind of growing on my face there. So back in December, I started working on that full time. So one of the open source projects I've been working on is something that helps address this. So first off, configuration management, or it's not enough. Acronyms are the worst. Software, or what's it, anyway, version control is awesome. It's the greatest thing. I am really obnoxious about that. And so there is Git, there is Mercurial, there's SVN.
There's only Git, come here.
Thank you, yes. Okay, well, so reinventing version control would be a horrible, horrible, evil idea, and we're not going to do that. But so actually, I wonder if I can stop this horrible blinking.
We can turn the projector.
Okay.
I think it's just your computer went into like sleep mode, or you turned off the sharing or something. It's back up.
Or if you want to show code, you can show code.
Okay.
Oh, we can turn it off. So.
Yeah. Okay, so this was something that actually I've been working with for a long time. So my background with Puppet actually started when I worked at Portland State University, specifically in the College of Engineering and Computer Science. And so we had, you know, not a lot of systems, about 180 systems. But the big thing that we can say is that, like, those Puppet manifests, let's see if we can actually make it back to, I think I may have misplaced my presentation. There we go. We can just slide up my speaker notes. So we are just writing code right here. So with any sort of code, you could you know, like, make a change and then copy file to like .back, or use version control. So we started just having a single version of we started versioning everything in Git, and that's just one branch that we rolled out. So if you want historical revisions of code, do not ask us to build something new for you, because there are many very good tools out there right now. But what we can offer is much better integrations with those tools. So
yeah, that's what I was thinking, because I'm using Git or whatever, but I want to know that when I made that tag or did that push, that all of my Puppet servers, all of the Puppetized machines got the change. Right?
There's a handful of things of, like, let's say, branching, merging, diffs, rollbacks, and things like that. That's handled entirely with respect to Git. For the aspect of blasting out configurations and making sure you're uniform, that hooks into the reporting system again. We're working on some very interesting new technology that I can I'm not going to talk about right now because it isn't complete, and I will give you wrong information. But we're working on a system of saying we've made it like revision X. Go out, kick all the machines right now, make sure in the state, and report back when you're done. Or this is let's say we're running a bunch of web services.
That does address both issues because A, it addresses my issue that I know that all the machines have acquired the new state.
Yeah.
But presumably, if this thing has some kind of memory, he can use it to see that last week we were still running the old configuration.
Yeah, that's the.
Yeah. Okay. So.
At what time point were you running what revision?
Oh, I really wish I had a copy of. I should have more an environment built up to demonstrate that, but unfortunately I don't. But yes, given the reporting system, you can say this, or at this time this machine ran this catalog, and here's what changed. Or you can say, or nothing changed. One very common, or so whenever Puppet runs, it along with that catalog that it generates, it will bring along a config version. What many people frequently do is that's just to get shot. So at this point, we applied this catalog, these changes were made, and we store that. So you do have that historical accounting for. With respect to what version of code was most recently applied, you can use the most recent report to say what happened last, what was the most recent version applied. Or you can proactively just poke the node and get them, or contact that node and get that information from it. So there's kind of a story of both how do you manage the code itself, how do you deploy it, how do you isolate it, and how do you make sure deploy it to your central location to be distributed, and how do you know it's been successfully distributed. So the horribly named project that I work on called R10K, that handles a lot of getting code onto that central location, isolating different versions, and things like that. We're building tools right now that say, okay, this R10K shows up, it makes some changes, you now have new code. This deployment service that we're working on, it says, oh, something changed. I need to update this, and this node. And when it's done, you'll have that information. So I think I've managed to circle around this and answer it like 3 ways and 3 times, but does this answer your question? Or okay, can I provide any more detail? Or I can ramble all day as I'm demonstrating.
Okay, so no, so
No, I mean I think there was I think there was 2 different questions there. One was talking about rolling code forward and back on your Puppet master environment, and there was a second one about investigating or introspection against convergence in the environment. And I mean I think it'd be good maybe to give an example about rolling code forward and back, like what it might look like. Okay.
So the tool I wrote and worked on, R10K, it has a fairly simple idea of we have this lovely thing called Git branches, and they're fabulous. Puppet has a concept of Git environments. Puppet has a concept of Puppet environments where it is just one isolated code. So everyone here more or less familiar with using lightweight topic branches? Okay. Is anyone not?
Not really.
Okay. So have you used SVN very much?
I've used Git some. I've used SVN a long time.
Okay. Well, so with SVN, basically every change is more or less going to happen on the master branch. Like once in a, or it'll happen on trunk rather. So once in a long while, you may have a branch for something that'll go on for a long time, but if you're making changes, it's going to happen in master every time. And that means that if you've got like some partial feature that you're incrementally developing, everyone else gets to notice that you're working on developing that feature as well. So with Git, Git makes branches phenomenally cheap. They're extremely efficient, they're extremely lightweight, they're very quick to use. So a very common workflow is every single feature or every single change that you need to make, if it's not completely trivial, you make a new branch, you do a bunch of your commits, and then when you're ready, you can merge that entire block in. So this allows you to, in your own time, you can incrementally build up work, don't affect anyone while you're developing, and it's isolated. And so what R10K is, it takes that idea of branches are light and cheap, and we should make a lot of them, and just match them to Puppet environments. So when you've got a Puppet agent that wants to contact the master, by default, it just grabs the production branch. What if you want to test it and do some like dev work? You're just playing around a little bit. You can switch that node into a new environment. It is as easily as you switch a Git branch, you can switch a Puppet node into a new environment. So it's like developing on Git branches, except it happens to be running on a VM or a server somewhere. So you get the isolation of Git branches and Puppet environments, And that'll give you the authoring aspects that you need of building up features and such. So again, it's really good at rollback. I mean, I can personally attest to this. Previously I was a core developer on Puppet itself. I broke things more than once, and there are a number of times I pushed some code. I thought tests were passing, and I was wrong. I immediately did a git revert, pushed a new commit, rolled back all my changes, and for 5 minutes we had bad changes after we rolled back. And so you can see.
Do I have audio? Oh. All right, how's this?
Was on for about a second and then again.
Wait.
Oh, yes.
Wait,
Yes,
do we have it?
yes. Okay, good.
Okay.
All right. So going back to the, okay. In what way is the Puppet must be not a special snowflake? In the sense that if I had a way of replicating config files across machines, some kind of like default service, that's whatever, doesn't matter. What are the advantages of actually having essentially a control node as opposed to having like a master list? Because I know some people are running Puppet kind of master lists by pushing config files in other ways. So is there anything about that?
So I would argue that masters are not actually special snowflakes, because I actually just like arguing, and I'll just stop there. No, so what we actually do, so we have a commercial product, Puppet Enterprise, and so when you have nothing configured at all in an environment, you need some sort of beachhead or something like that. So you need to get something started. So our initial service comes along, you get one Puppet master. If you want to make another node, and so you want another node, bring in another agent, connect it to your master, and then tell that agent that it's also a master. You get another master. And when I was working in operations, we would spin up Puppet masters all the time. You can use serve records to do distribution. You can do DNS round robin.
But I mean, a Puppet master to handle your Puppet master. So.
Yo, dog. Or
yeah.
You can. My experience is that, well, in the same way that like with M Collective, you need a message bus to communicate. You need some sort of central place to do that. You don't have to. So as you mentioned, I've been describing a model where you have one single master and you've got a bunch of nodes connecting to them. What this does achieve is you only have to have one copy of that code. It's on your master, and everything. The nodes get all their information from that one location. You can also do what was touched on master lists, where you can distribute your code to all your nodes. Once again, using R10K because I have to push that. I wrote it. But in some manner, you need to get your copy of your Puppet code onto all your nodes. And so the centralized method would be Puppet agent -t. That'll connect to your master. You can also just do Puppet apply, and that is a local method where Puppet will start up. It'll find its configurations. It'll build that catalog, and it'll run that locally. That's entirely decentralized. In some situations where if you expect to have a ton of nodes coming online all at once, that might be more efficient in some ways. You do lose some of the. I believe so. I'm wonderful. Okay.
That's what Spotify does.
I was about to say, a long time ago, when when PuppetDB was originally written, there was a bug that made this harder than it was necessary. Or there is a weird dependency cycle. But we actually, wait. Let's see if did I lose my audio again?
Keep on.
Okay. Do we have anything?
It's showing audio here.
Okay. Okay. Perfect.
Both my system and your system.
Yeah, apparently my computer really wants to turn off its monitor, and it's not playing nice. But where was I? Oh yeah, Spotify. So this was an issue at one point, but Spotify, their guys use Puppet very, very heavily. They use it in the master list form. If Josh says that they use master list with PuppetDB, I would believe them. In some way, or what is nice about having a centralized master is that all your agents, they're stupid. They have, you can say you will get this version of code no matter what. I'm not going to give you anything else. When the node itself is controlling it, it can be like, oh, I'll use this copy or I'll use that copy. So, if you're doing effectively simulation with your own resources and you do not have a lot of forward-facing services, and it only affects you if you make changes, it doesn't matter at all. If you are running some sort of web application or you're providing a service and you say this cannot go down and you have to be very prescriptive about, or very careful about rolling out changes, then it's nice to say that this code is locked down on this node. You can do that very, very easily with Puppet Master or a centralized configuration. But once again, if all the control is on the edge node, then there's nothing you can do. Is one better than the other? They have pros and cons. I think that just using configuration management, and preferably Puppet in whatever variety works best for you, awesome, do it.
So along the lines of pros and cons, you know, it's specification of preferences, especially when they're paying for your bandwidth. But you know, could Could you spend a couple of minutes talking about, for example, the chef model, which is a little bit different than Puppet and compare and contrast. So chef has a like a DSL, right? It actually has a code instead of a configuration.
Yeah, it is.
It's a command system as opposed to configuration system. Is that fair?
Yeah. So I can give you a rundown of what I understand about Chef. I've never really played with it. I have totally stolen their good ideas, though. I mean, one of the great things about open source is like, I like that. We're ripping that off. And Chef originally did that to Puppet, so we could steal back too. So Chef, so with Puppet, we have a configuration, or it's a Turing-complete language, but it has a simpler syntax. Basically, it is just what can I say about it? Once in a while, I'll go into a rant where like having a full, robust Turing-complete language is absolutely great. And there are also cases where having a full, robust Turing-complete language will let you do some truly horrendous things. I can actually give a fun little example here. Let's see if I can boost the font. Oh, actually, I'm not sure this is going to show up. Let's make it show up. And hang on.
And sharing is now looking at you.
Wait. Okay, did we get switched? Perfect. Okay. So Chef has a DSL, and Chef is all the configuration is entirely in Ruby, which can be fantastic. But you can do things like, let's say, okay, so here's a string, right? What does this do? Let's do what's that gonna do?
According to the number of bytes.
Wait, oh, I did something quite not entirely correct. Wait. There we go. So Puppet is designed. It is not supposed to be a fully robust programming language. Like we are extending some of the functionality for it, but the original impetus is make a language that is good at expressing configuration and things like that. I've got some friends that work at a company called Urban Airship, and they use Chef. And one of the things they like to do is giggle about the horrendous things they do. Clever, like I've also learned as a developer, like it can. Chef has the advantage that if you know Ruby, it's absolutely fantastic. It also has the downfall that you can do anything at all. I find that in some ways it gives you flexibility in places you don't need. It can become too complex. But so that's just a language. I mean, we have our own DSL. I'm pretty fond of it. I think it's very good at expressing configuration in an effective manner. And for very complex concepts, it offloads into it offloads. So you get a clear delineation of here's my configuration and here's where I'm munging data. So that's my preference. But we're adding some more robust features that allow you to do slightly more complex things without completely blowing your leg off.
If I have a situation where I'm applying a Puppet config and it doesn't converge and I have to apply it a second time for it to converge, is that okay, or is that telling me that I have a flaw in my logic somewhere? People differ on how they treat this kind of thing.
In some cases, one of the things that is currently tricky that we're also working on, like I mentioned, this model of being like doing just push deployments and, well, actually let's start with there, where we have a push model where nodes are notified when code is changed, and we have a better concept of code and nodes. One of the things that I don't think many tools do terribly well right now, like some do okay, but it's like I want to spin up app server A that connects to database B, and I want it to be put in load balancer C. So in a case like that, you may have to incrementally stand up machines, and convergence like that it's hard. We are working on solving that right now. Once again, it's not my project. I don't know the details, but our prototypes look like it's a very cool way of saying declaratively, I have this service over here. I've got a web service here, load balancer, database. Here are the relationships. Spin these nodes up and do whatever you need to do order. So one of the things that Puppet does is, and I'll compare it to Chef. So Chef has, they're effectively is cookbooks, runbooks, something, where it's, Chef goes through and says, I have a resource here, I have a resource here, I'll have a resource here, and it'll do that in this order, which is kind of cute. I'm a jerk. But so let's say I do X, or I have steps A, B, and C, X, Y, and Z. C fails, and X, Y, and Z are entirely unrelated. Do you want to skip X, Y, and Z just because something entirely unrelated failed? So my personal preference is I'd rather get done what needs to be done, especially I've had situations where, like Ruby gems, the Ruby package distribution system, they have issues with outages. GitHub for a while, like they just like to fail once in a while, and it would just break a lot of things. And so I'd rather have as much get done as possible, and then I can go back and remediate the individual failures, rather than have everything crash and burn right away. So there's that approach. But so for Puppet itself has a better concept of ordering, where things in Puppet 4, this will change. By default, we will say if you put resource A before resource B, unless there's another reason to reorder things, we'll do A and then we'll do B. But if you say A, let's see, so we have resource A, resource B, which depends on resource A. No, sorry, that wouldn't work. Help, Josh.
I think you had a good example in your slides earlier with the services where you have some ordering directives and before directives.
Let's switch back to that. Thank you. And we're looking at my face again.
The Chef doesn't have those kinds of directives?
It does not. Let's see if we actually shared what I wanted to. Wait. There we go. Yeah, close enough. Come on. There we go. So for right here, we have, this is a pattern called package file service. So first thing, you have a package you want to manage. So you say it needs to be installed. And then you'll say, like, obviously, you want to have the package installed before you lay down configuration files, because, you know, package, like, you lay down your configuration file, package is installed and stumps that. So you say, there's this relationship, install the package, and then put the file in place. And so we do that. And then the next thing, so we want to have that package in place, we have to configure it, and then we want to make sure the service is running. And so we have this relationship between these two where install package, then install file. And then for a given service, every time this configuration file changes, like let's say we install the service, get everything going, we modify that configuration file, we have to restart the service. So we have a relationship between the SSH service itself and the file. So through this subscription, where whenever this resource changes, we will restart that service. So this is where you can argue about which one's implicit versus explicit. But in this case, we are declaring direct relationships between different resources where necessary. So the new behavior is with Puppet is when it's evaluating resources, it'll say there's this implicit order. There's no reason to change anything else. I'll just go through this. But if we said that if we had the package last, it would still get ordering correct. So actually, ooh, this is nice because I can use the term acyclic directed graph. Puppet builds an acyclic directed graph of relationships. By default, it'll we do what amounts to a topological sort of the resources to get the correct ordering. But the topological sort takes into account like their order in which resources were declared. So if there's no reason to put one before the other, it'll use the file ordering. So, and you can get consistent. You can. Well, one more thing that's actually kind of handy. If you want to make sure that, like you said, how many times should I have to run Puppet? Like if it fails, should I just run it again? There's a. I think this changed in like 3.4 or 3.5 or 3.6, where let's say you want to effectively fuzz your configuration to make sure your ordering is correct. The default behavior is to have that manifest ordering. You can also specify a random ordering, so you can say, let's introduce these failures. Let's make sure that our ordering is correct. So yeah, very snazzy feature. So you can make it as chaotic or as orderly as you want. Yeah, Yes. I think there may have been another question asked, but I got excited. Do you have something? Yeah. Yeah.
So how's public open source different with public enterprise?
If you repeat the question, because we're using your laptop,
Okay.
So they're not going to pick up that sound.
So the question asked was, how is Puppet open source different from Puppet Enterprise? Well, the Puppet package itself looks at, instead of Etsy Puppet, Puppet.conf, it looks at Etsy Puppet Labs, Puppet.conf. That's also, our core products are open sourced. Factor is open sourced, Puppet is open sourced, PuppetDB is open sourced. What we are interested in doing is for commercial products where, for newer, either extremely crazy large environments with thousands of developers or people with people that are that need some handholding, we have a few things that are. I've been open source for a very long time, so I don't know everything that's offered in the enterprise stack. But for one thing is we offer more graphical components. So yeah, management screens and nice question mark buttons. So what we've been working for though is like if it is for a gigantic shop with of people that may not be the most robust users, that's where we're targeting some graphical components. The APIs will always be open now. So PuppetDB, robust API will be exposed. I don't know what else we're working on, but yeah, that's basically our dichotomy that we're shooting for. I, being a filthy hippie, push for open sourcing as much as we can, but I also like getting paid. But that's roughly the dichotomy. If we see a lot of interest in, and especially like client-side things, like we currently changed our implementation, our facts gathering implementation from Ruby to C. This client-side, it's open source. Contributions very happily accepted. Yeah, and the other big thing is too support. No comment. Let's go with that. We have people that definitely need support, and let's leave it at that.
There aren't modules that are enterprise and not offered to users?
I know that there are modules that we bundle with Puppet Enterprise. Like there's the Puppet. Oh, so you were mentioning the Puppet Labs Reboot module. Someone's been working on Linux support. So, but Puppet Labs Reboot, we bundle that. Puppet Labs ACL, I think we bundle that. Internally, we use Puppet itself to bring itself up. So that module, if you want to bring Puppet Enterprise up without using Puppet Enterprise, then so there's that one.
So pretty much not.
There might be like I think there's the. I think there's. Yeah, by and large, we like graphical components. Those tend to be commercial. The other thing is where if we had to feed or basically sacrifice developers to unholy beings, those go closed source. The big example is the F5 load balancers. I think that we did a closed source rewrite because it was phenomenally costly. Like, it was an incredible amount of work. It is extremely taxing. Maintenance is through the roof, just because, I mean, they don't give APIs for that. So it's a case where, I mean, we're trying to recoup our losses or something like that. That may go commercial. If it is another commercial integration, like if we integrate with Perforce in some manner, if someone's burning a ton of capital on that because they don't like Git, like we'd kind of like to hold out a little bucket for that. And also, once again, AIX is an enormous, enormous cost. Puppet itself will.
Trouble understanding that AIX would switch so bad.
You and me both. The Puppet itself, when we make any sort of modification for AIX for Puppet, that goes open source. That being said, I'm not sure if we offer packages. So if you can get Ruby on it yourself, it's great. It's great. So there's things like. We offer actually that's the biggest thing too, is in some environments we just offer slightly better packaging because especially like AIX, I did something stupid a long time ago. I was working on Factor and I said, hey, there's this weird bug I want to test. Do we have an AIX box? I didn't know what AIX box, and they said, oh, we have one, but it's not set up. Do you want to do that? And I was like, sure, how bad could it be? I know now. So that's the rough boundary, but I mean, we do have a lot of people that we like open sourcing as much as we can, but there are things where it's like, we actually open source one component and no one cared. And we're like, it's still nice for commercial users. The open source community does not care at all. So it's nebulous. We're still working it out. Like I said, I'm a dirty hippie, and I push to open source as much as I can. But it's also nice to be paid and stuff. So.
All right.
Yeah.
I think we have to give the room up. So thank you very much.
Thank you very much for having me.
Thank you, Ian, for the
Sorry for the technical difficulties.